Welcome and hello. This is a video exercise in HEC RAS. And in this exercise, we're going to be dealing with a 1D steady flow HEC RAS program. So this is the first exercise. It's going to be fairly straightforward. Hopefully, we're going to get started here. All right, what I have on the screen is HEC RAS. I'm using version 6.6, but what I'm doing here should work for other versions. And yeah, let's get started. First thing is to go File, New Project. And as you might imagine with these exercises, I'm going to go through every step. I'm not just going to isolate one particular topic, which is what I do for the lessons. So this is a whole different playlist for projects. And let's get started by naming the project Exercise 01. Now I need to find a location for the project where I want that project directory to be located on my computer. So default project folder, this will take me to my default project folder, which I have defined in HEC RAS already. I can show you how to set that up. Exercises 1 project. All right. So exercise 01, I'll click OK. Title and file name must be specified. So 01. Okay. I should probably navigate to the project directory first, then type in the title. So now the title and the file name are right there. Click OK and OK. If I bring up my project directory, it's right here. I have my exercise 01.prj. All right. Let's get started by creating a geometry file. So I'll click on the View/Edit Geometry button right here. I can also go up to Edit Geometric Data. That opens up the same window. All right, what we have is our geometric data editor. And what I'm going to do is just sketch out a simple river with one reach and then add some cross sections and then save that for my geometry file. So I'm going to start by going up to click on this river reach button right here and then sketch down from top to bottom, sketch in the direction of the flow. And I should probably also mention that this view, sometimes I'll set the schematic to something larger than just one by one. So like 10,000 by 10,000, for instance. But when I click OK and then I go back to the view, it sets it back to 1. So I'm just not going to deal with that. This is not a geo-referenced geometric data file. So I'm just going to let the numbers of the cross-section speak for themselves, not need to change the view per se. All right, so anyway, with river reach selected, I'm going to sketch in the direction of flow. I'll just add a slight bend and then double click. So I'm starting with a single mouse click and then adding another single mouse click at every vertex, double mouse click to finish, and then we need to name the river and reach. I'm going to call it river A and reach 1. I'm only going to have one river and one reach, so that's almost inconsequential. Now let's go ahead and add some cross sections. So we'll click on the cross section button over here. And what I have is a table for the cross sections to be defined. I need to actually add a cross section first. And what I like to do is start from the bottom of the reach and work my way upward. So I'm going to click on Options, Add New Cross Section. I'm going to say 0 for River Station 0 at the very bottom of this reach 1. I'll click OK. And now I need to define the data right here. I'm going to leave the description blank. That's optional anyway. But for the cross section, I need to start typing in data. So now this stationing here is the stationing of the cross section, not of the river reach. So the river reach would start at river station 0 and work its way upwards. The cross section, I'm starting on cross section at river station 0, which is at the bottom of the reach. That's going to be facing in the direction of flow from left to right. So let's just add some numbers in here. And then the last value will be at 1,000 feet across, elevation of 90. So what this cross section looks like is, I'll have it up in the preview in just a moment, but it's going to have an invert of 30 right here across the main channel with a width of 200 feet. All right, so the downstream reach length is actually going to be 0 because I'm at the very bottom of the reach, but it will have a positive value for the other cross sections that I define. All right, leftover bank Manning's N number, I'm going to say 0.05. 0.03 and 0.05, a little bit less for the main channel. And then the left overbank will be 300, right overbank will be 700. And now if I click this apply data button, I see the preview pop up over here. If you don't have this preview, you can just toggle it on and off using this button right up here. And what we see is the Manning's N is 0.03 for the main channel, and then higher for the left overbank and right overbank. All right, I'm going to add a few more cross sections here. This is just the very bottom. So I'm going to add one maybe every 1,000 feet for a few thousand feet. To do that, I'm going to select my one and only river cross section that's already been defined. Options, copy the current cross section is probably the fastest way to do what I want to do here. So I'm going to click copy. Now what I need to do is define the river, the reach, and the station. I'm going to say this is now 1,000 feet upstream from the bottom of the reach. Click OK. Now what I want to do is change this downstream reach length to 1,000, and then I'll copy that over for the main channel and the left overbank and right overbank. It may be a little bit less in reality if the river's turning, and I'm just going to assume that it's a straight river section for now. All right, the other change that I want to make is increase the elevation of the invert slightly. So I'll do that by going up to options, adjust elevations, and then I'm going to just increase it by 2 feet. So I'll just add a 2 there, click OK, and then those values all increase by 2 feet. Okay, so I'm not being super creative. I'm keeping basically the same cross section, just increasing the elevation by a little bit. Let's go ahead and do that once or twice more. So options, copy the current cross section. This is going to be 2,000 now. Okay. Everything here looks good, except I want to increase the elevation again. This time, let's just increase it by 1 foot and see what that looks like. So adjust elevation, add 1 foot. Okay. Apply data. And then let's go ahead and look at the profile. So plot profile. And what we have here is the lower 1,000 feet of the reach is at this 0.2% slope, but then it levels out a little bit. It's only 0.1% on the next 1,000 feet of river station. So I'm going to go ahead and just change that back so it's a constant slope. So to do that, I'm just going to go to this top river station. Let's add 1 more foot to all the cross sections like that. And then apply data and then plot profile. Boom, there we have a constant slope. All right, let's do that one more time and then add intermediate cross sections, save the geometry file, and then move on to adding some flow data. All right, so copy current cross section. This is going to be now 3,000 foot. Okay. Once again, I'm just going to add 2 feet to this cross section, adjust elevations, 2, okay, apply data, and then let's check that profile one last time. Looks good. Let's go ahead and add some intermediate cross sections. So to do that, I'll go up to, oops, it's not here. I need to close this. I see the 3 cross sections that I've added to the reach already. So even though the view schematic shows that this is only 1 foot, I believe, but the schematic is correct because it's based on 1,000 foot of run and then a 1,000 foot of cross section, if that makes sense. So the total reach length here is 3,000 feet, and then each of these cross sections is 1,000 feet across. So it looks like it's to scale. All right, let's go ahead and add some cross sections now. I'll go up to tools and then cross section interpolation. Say for instance, within a reach, what we want to do here is just add maybe 4 cross sections, like at every 200 feet between these cross sections that we've already defined. This is a way to add multiple cross sections quickly if the assumption of linear interpolation is valid. So I'm just going to come over here, type 200 for all river stations. Yep, and for the river and the reach, that looks good. Interpolate cross sections and click close. Now, boom, look at that. We've got a bunch more cross sections for the model. These interpolated cross sections do have a little asterisk mark by them, so just keep that in mind. And we're good to go with our geometry file. Let's go File, Save Geometry Data, Exercise 01. This is going to save as a .g01 file, I believe. So here is my files. Right now, let me go ahead and save or click OK. And then here's the files now. It added a exercise 1.g01 file, as well as the associated .hdf file. All right, let's go ahead and add some flow data now. I'm going to go up to Edit and then Steady Flow Data. Another way to open up this dialog box is to just click on this button right here. And what we have to do is define the flow rate with different profiles, as they're called. So let me make that smaller. By default, it only starts off with one flow profile. So I could type in, say, 100 CFS, save it, run, and see what 100 CFS looks like. But it's a little bit more interesting, especially if I'm trying to define a rating curve, to add a few more profile values. So I'm going to change this to 4. And then instead of 100, I'll have a second profile, which is 1,000. 10,000 and 100,000. All right, that looks good. Also, what we need to do in this dialog box is define the boundary conditions. So I'll click boundary conditions, set boundary conditions for all profiles, check. And then the boundary condition for upstream and downstream, I'm just going to set to normal depth. And then I will use that constant slope of 0.02, 0.002. It's a 0.2% slope. All right. And then same thing for the downstream end. And then click OK. All right, so that looks good right there. I'm going to save this steady state flow file. So file, save flow data, exercise 01. Gonna copy that to my clipboard and then click OK. Now we have a .f01 here, exercise.f01, and we can close this out. So save flow data, got it, and close. You notice I do have the geometry data editor up still, and I don't need it up, but I do kind of like to have it in view, even though I'm not always going to be using it. That way I can kind of remember what my river reach and what the schematic and geometry of my project is. All right, let's go ahead and create a plan and run it. So run steady flow analysis. Another way to get to this dialog box is to click the stick figure that's running on flat ground there, steady flow analysis. And what I'm going to do here is define the plan, which is going to be using my geometry file, exercise 1, and steady flow file, exercise 1. That's the only geometry file and steady flow file to select. So file, I'll save this plan here, and then I'll just paste in my exercise 1. I'll start naming things a little bit differently as the need arises, but for now, that's fine. So I'll click OK. And then the short name here will also be exercise 1. So those values popped into place here for plan and short ID. All right, everything is good for now. Let's just go ahead and click compute and see if this runs. Okay, so that ran fine. Just took a moment, 4 profiles, and then click close. Let's go ahead and look at some of the data, some of the results. So I'll close the steady flow analysis dialog box, click on view, and then click on cross sections. So right now I'm seeing the cross-section data for the results shown right here. Exercise 1, plan exercise 1. This is River Station 3000, so this is at the very top. And then if I toggle up to, or down rather, to the bottom, now it's highlighted over here in the geometry data. That's one reason to keep it open. It sometimes highlights what you're looking at. But the flow is way down here because this is for profile 1, hence key F1. Let me go ahead and add all 4 profiles so you can see what that looks like with not just 100 CFS, but also 1,000, 10,000, and 100,000. I'm going to go up to options and then profiles. Right now, PF1 is the only one selected, so I can just select all, click OK, and boom, now I have all 4 profiles loaded. This is a little bit busy because you notice the legend reports the water surface elevation in blue, the energy gray line in green, and then the critical flow in red. I'm going to turn off critical flow and energy grade lines. So all we see in the plot will be the water surface elevation. Options, variables, and then I'm going to uncheck energy grade and critical depth and click OK. All right, so this is a little bit easier to visualize now. We see for this bottommost cross section, the water surface elevations, where we have 100, 1,000, 10,000, and then 100,000 right here. Since the cross section is pretty much the same for the entire reach, if I toggle up to the next reach, it's pretty much the same. There's nothing really different to look at. There's no bridges or culverts or flow changes or anything like that. And I wanted to keep it simple for this first exercise, just to not make things too confusing. I am going to make a few changes though. For instance, I'm going to add a few more flow profiles so we get some flow over the overbank. So to do that, I'll close this, go back up to edit, steady flow. I'm going to change it from 4 to 6. So I'm going to add 2 more flow profiles. All right, so here they are. Now I'm going to type in 250,000 and 400,000 right there. Okay, file, save. It's saving it to the same flow data file. So I don't need to update the plan. It already knows that it's using this steady flow, and then click compute. Okay, so that's computed. So I'll close that. Let's go back to the results now. View cross sections. And now we need to add those last 2 profiles into our plot. So profiles, you can just double click or you can single click, arrow over, that adds it as well, and then click OK. All right, cool. So these top 2 blue lines represent 250,000 CFS and 400,000 CFS. And again, all the profiles look pretty much the same. One thing I like to do when viewing plots like this is to set the persistent scale, at least for the vertical axis. So I'm going to go options, set persistent scale. And what this will do is to fix the vertical axis to whatever I set it to here. As for x-axis, that's fine. But the y-axis, I'm going to say 30 to 100. And I'll leave the step at 10. That looks good. And then click OK. Now when I toggle up the cross sections from the bottom of the reach up to the top of the reach, it's not changing the axis values in the vertical elevation. So that's just preferred by me. So I'm just going to toggle up all the way through. You can see very easily the water surface elevation is increasing as well as the channel geometry itself in elevation. Next, I'm going to view a few other results. So I'm going to close the cross section, go up to view, and then water surface profiles. Here we have the 6 different profiles and their water surface elevation. Again, we're looking at it from like a side view now, where the river reach 0 down here is on the left, and then river station 3000 is up here on the right. We could also add the variables back in here, but I'm not going to do that because that could make things really busy. As you can see right here, it's almost too many lines to keep track of. Options, variables, and then let me toggle those off again. Okay. I'm going to close the profile plot. The next option is, let's look at the rating curve. So the rating curve here now takes into account the different flow rates from, well, we started with 100 and then we went up to 400,000. So you can see how that rating curve was generated. We could probably add a few more intermediate points though if we wanted a smoother curve. Okay, I'll close that. The next view down, the next option for results I'm going to look at is XYZ perspective plots. And I've got all the profiles loaded here, so I'm going to go ahead and toggle off some of the profiles. In fact, let's turn all of them off except profile 4, which is the 100,000 CFS profile. And now we see where that lies. Not too exciting because, again, it's like constant cross section. But if we're looking down on it, the flow would be in the downward direction. And we can just kind of change the view. And this is a cool way to visualize the results, at least when we have more to look at, not just a constant profile for the geometry. All right, so let's go on to the next one. View menu, profile summary data table, the summary table here. What this is it looks at just one particular profile, like profile 4 right now. And there are different standard tables to look at and different options and ways to include different profiles as well as the different time steps as well. But that would be for unsteady flow. This is only steady flow for this exercise. But what you see here is the flow rate, which is more than 0. It's just getting cut off here. So let me make this column wider. Yep, 100,000 CFS. And then what we have here is the channel invert. So it goes up from 30 all the way to 36 at the highest cross section. You see the water surface elevation values, critical depth, energy grade line, slope, and so on. This critical water surface right here is only calculated for the bottom-most cross section, but we can have some control to toggle that on and recalculate if we want. So let's go ahead and do that real quick. I'm going to go back to the simulation options, steady flow data. That's not it. Run. Okay, so steady flow analysis. That would be accessed from run steady flow analysis. And then I'm going to click on options and then critical depth output options. And I'm going to check this checkbox on and then click OK. While I'm here, I should also probably point out that the next menu item down is critical depth computation method. And I'm just going to stick with this parabolic method. That's fine. But there's just 2 different things here. There's critical depth, whether or not you want to calculate it. And then if you do want to calculate it, how do you want it calculated? By clicking on this one. All right, so let's run it. All right, that ran. I'll click close. Now let's go back to view the results. So view profile summary table. And now we have data in this critical water surface column of the table. All right, one final thing before we sign off here. I want to check out the profile with all those critical depths, but for only one profile. So view cross section. Now we're only looking at this PF4, the profile for 100,000 CFS. But now I'm going to toggle on the variables that we had turned off originally, energy grade line, critical depth. And we have the energy grade line in green, the water surface in blue, and then the critical depth in red. And I can toggle that off and just see how it increases with the different river cross sections. All right, well, that was it for this exercise. We built a basic 1D steady state flow model in HEC RAS. We created the geometry file, we edited the flow data and set the boundary conditions. Then we ran the simulation and viewed the results.